Hello friends, welcome. In this video, I will be discussing the performance standards of the SART, Search and Rescue Transponder. I will try to keep these things in a sequence that it will be easy for you to remember. So let's get started. If you have seen my previous video on EPUB, then you know there are certain common points which are common to life-saving appliances. So I'll start with those common points. First one, that it should be watertight at a depth of 10 meters for at least 5 minutes. It should maintain its water tightness when subjected to a thermal shock of 45 degrees under specified conditions of immersion. The SART should be capable of withstanding without damage a drop from a height of 20 meters in water. The SART should also be capable of floating if it is not an integral part of the survival craft. It should be resistant to deterioration in prolonged exposure to sunlight. It should be of a highly visible yellow or orange color on all surfaces where this is to assist detection. The SART should be so designed as to be able to operate under ambient temperature of minus 20 to 55 degrees centigrade, which is same for EPUB. It should not be damaged in stowage throughout the temperature range of minus 30 degrees to 65 degrees. In case of EPUB, it was minus 30 to 70 degrees. To make your life easier, I want you to remember that these 6 points which I've discussed so far are common to the EPUB, except a bit of change in the stowage temperature range. Then continuing with the other similar points for most of the life-saving appliances, because this is battery operated, SART should have sufficient battery capacity to operate in standby condition for 96 hours. In addition, following the standby period, to provide transponder transmission for 8 hours when continuously interrogated with a pulse repetition frequency of 1 kHz. And before I discuss further, I want the viewers who may not be familiar with the SART equipment that it is an equipment which is used to give a homing signal to indicate that there is someone who is under distress. So imagine that a ship has already sunk, people are in the lifeboat, and there is a ship passing maybe at a distance of 5 miles or 10 miles. And this SART at that point can be used to give signal to the other ship that there is a person who is under distress. As soon as you activate the SART, which will be in the standby mode for 96 hours, it will start transmitting, which it will do for 8 hours. It will show on the X-band radar of the other ship that there is a SART which is activated in a location, and using that signal, they can keep proceeding towards the person or a group which is in distress. Now that you understand its working, the next requirement is that the vertical polar diagram of the antenna and hydrodynamic characteristics of the device should permit SART to respond to search radars under heavy swell condition. The polar diagram of the antenna should be substantially omnidirectional in horizontal plane. Horizontal polarization should be used for transmission and reception. So basically we want an antenna which will give signal in all direction, not just one single direction, so that it can be easily detected. Next standard is that SART should operate correctly when interrogated at a distance of up to 5 nautical miles by navigational radar, complying with the resolution 447 and 222 with an antenna height of 15 meters. It should also operate correctly when interrogated at a distance of up to 30 nautical miles by airborne radar with at least 10 kilowatt peak output power at a height of 3000 feet. Now you can see that same SART can indicate its position at a 5 nautical mile distance and also at 30 nautical miles. What I'm pointing out here is that SART is capable of transmitting at a large distance. The only limitation in this scenario is the height of the X-band radar scanner which is detecting this signal. If an aircraft is detecting this signal, it can detect at a longer range. If the ship's antenna is at 15 meter height, then it can detect up to 5 nautical miles. And now I come to the easier part. Easier part is, as soon as you see a SART, you can easily notice that there are some labelings, and these labelings have certain standards. There should be brief operating instructions, which you can see on the SART are there, and the expiry date for the primary battery used should be there. Now I have the SART equipment in my hand, and thus the upcoming points can be easily remembered if you can just remember how it looks. So first of all, the SART should be capable of being easily activated by unskilled person. So as you can see, there is a ring here. This is test side and this is on side. I remove this pin, I operate it. So there are no special skills which are required by a person to do this. So this is the first standard, which is easy. Secondly, the SART should be fitted with a mean to prevent inadvertent activation. And with this red pin, you can understand, as long as this red pin is in place, I cannot activate it. I have to literally remove this pin and then put it in the on position. And thus, inadvertent activation is not possible, and this is another standard. Then further, SART should be equipped with a mean of either visual or audible, or both visual and audible, to indicate correct operation and to alert survivors to the fact that radar has triggered the SART, which basically means that there is a ship which is passing by and now it is getting our SART signal. And the signals on the radar looks like this. As the target or the SART gets closer, the dot becomes arc and arcs becomes full circle. Like in this case, I'm testing my onboard SART, which is very close to the X-band radar scanner, thus full concentric circles. Then the next standard is that it should be capable of manual activation and deactivation. Provisions for automatic activation may be included. So as you can see, I can manually activate it, and also if it gets into the water, it automatically activates through these electrodes. Then the SART should be capable of an indication of standby condition. SART should be equipped with a buoyant lanyard suitable for use as a tether if it is capable of floating. The SART should have a smooth external construction to avoid damaging the survival craft. And last point but not the least, it should be provided with a pole or other arrangement compatible with antenna pocket in a survival craft in order to comply with 2.4 together with illustrated instructions. And here you can see this is the pole which is provided on the SART. With this I increase the height of the SART, with that I increase the range of detection. Finally, coming to the technical characteristics. Technical characteristics of SART should be in accordance with the recommendations of ITU-R, which is basically your International Telecommunication Union, and R stands for the radio communications sector of the ITU, which is basically your GMDSS, because this SART is also a part of GMDSS. I hope this sequence will be easy for you to remember, just basic LSA points. First 6 points are common to the EPUB, making it even easier. Then further points are what can be expected from a SART. Then I spoke about the labeling, 2 points only. And finally, what all you can remember after seeing it visually, and the technical characteristics, that it should be as per the recommendations of the ITU-R. I hope this was a useful video for you. If you have any feedback, suggestion or comment, then please do write down below. All the best for exams, and as always, thank you for watching.